Hey guys, so in today's video, we're pretty much going to review everything that we did right before spring break. So that week right before, we're going to try to condense it together in one quick video here. So right before we went on spring break, we started a new unit on similar polygons, right? So shapes that are similar. So there's a couple definitions I want to go through and a couple examples. But again, today's objective is going to be to take a look at two similar figures, and again, find a missing side, write that similarity statement, and prove whether two figures are actually similar or not. So what are similar figures? What are similar polygons? Basically, when you dilate polygons, similar polygons are created, right? So again, it's the same shape. If you can make this part here, it's the same shape, but just different size, right? Just depending on how you look at it, which way. If you're looking going from left to right, this was an enlargement, right? The shape isn't changing to like a circle or a square or some other different shape. It's staying exactly the same shape. It's just a different size. Or if you went backwards, right, you're just shrinking, you're reducing. It was a reduction, but it's still staying the exact same shape, just a different size. A couple other important characteristics though. When you have similar polygons, let's see if I can pick a different color here. When you have similar polygons, corresponding angles are congruent. So those angles that match up, right? So playing that matching game, they are going to be congruent. For example here, angle A, let's say this was 30 degrees. Well, then angle W, right? It's corresponding, its matching angle over here would also be 30 degrees. Even though it is a bigger shape, it's still, the angles are still congruent. What about the sides? Well, the sides, obviously, they're not going to be the same, right? If the image got bigger, obviously the sides should be bigger, but here's the other important part. When you have similar polygons, all sides are equally scaled. Remember those scale factors, whether you're multiplying by 2, 3, 4, 1/2, 1/3, 1/4. All sides should be equally scaled if they are similar. What I mean by that, take a look here. Going from a length of 5 units, now it turned into a length of 15. This is just a scale factor being applied here, multiplying by a scale factor of 3. And so if we do have similar polygons, then all of these sides should be scaled by the same thing, right? So take a look. 3 times 3 gives us 9. That checks out. On the bottom side down here, 2 times 3 gives us 6. And then on the right-hand side, 4 times 3 gives us 12. So all these sides are equally scaled, right? So these are the characteristics of similar polygons, similar figures. And don't forget, when we do have similar figures, we like to write this similarity statement. That little squiggly right there, it means similar. They're not exactly the same, right? One's obviously just bigger than the other. But again, the order does matter. And this is, again, this is going to help you play that matching game, right? Rely on this similarity statement to tell you, hey, which angle is matching up to which angle is corresponding to which other angle. And the order does matter. Take a look here. A was the first letter, is similar to W. So angle A here, and we see it with one marking, it's similar to angle W, right? So those are the corresponding angles, right? Again, if this was 30 degrees, angle W would also be 30 degrees. You also can play this matching game with the sides, the actual sides themselves. Let's take a look at the last two letters, C to D, the distance from C to D. So that side right there, that bottom side, should be corresponding to, take a look at that similarity statement, the last two letters, W and Z. Okay, so again, don't just kind of try, don't just eyeball it, right? You have to make sure that you come back and look at the similarity statement. So again, use it to your advantage when you're playing this. Pretty much what it is, it's just a matching game. So let's keep going here. So example number 1, it says name all pairs of corresponding sides and angles. So let's start off with just naming all of the corresponding sides. All right, just which sides are matching up to which sides. So I don't even really have to look at the figures themselves, right? And they are all a little bit jumbled up, right? They're kind of reversed, flipped around. So I do want to rely on this similarity statement right here to tell me, hey, what side actually is matching up to which other side? So I'm going to use the first two letters here, L, M. So from L to M, that should be corresponding. It should be matching, right? You can't just assume that it's ST or TR or RS, right? You have to make sure that you're careful. You can't just eyeball it. Go back and look at your actual statement. So LM is similar to RS here. So from R to S. And so we're going to name that right here on this very first spot. LM, line segment LM, all right, should be corresponding to RS. S. And don't forget to write the little line segment symbol up above. Let's keep it going with the other sides. Let's go MN is the next one on our list. So I'll use the last two letters, M and N. So from M all the way to N, that's matching up to the last two letters over here are S and T. So MN is corresponding to line segment ST. And then, of course, the last one, right? It's kind of obvious here, but I'll go ahead and label it. We were using the first and the last letter, L to N. We're also going to use the first and the last letter in that statement there. So we're going to say R to T. So those are the sides that are matching up. Line segment NL is corresponding to RT. Okay, so that is just our matching game, corresponding sides. Let's go through and do the same thing, but this time we're going to do it with the actual angles. So which angles are corresponding to which angles? Let's go through and play that matching game. So let me use a different color here. So angles, now let's talk about angles. So this first one here is saying, hey, angle L is going to be congruent, right? That little symbol here is congruent. So angle L, I'll mark it with one little angle symbol, angle L, it's the first letter. It should be congruent to R. So here is angle R. So angle L is congruent to angle R. Let's continue to play that matching game. Move on to the next one. Angle M, I'm going to put two markings here to separate it so I can tell them apart, right? So angle M is the second letter, S is the second letter, so I'm also going to put two angle symbols there. So angle M is congruent to angle S. And then, of course, the last one's kind of obvious, right? N, 1, 2, 3 angle markings. That one's corresponding, right? It's matching up to angle T here. 1, 2, 3 angle symbols, so I can correctly label that. Angle T. Okay, so this was just the first example, just to kind of recap. Hey, can you name all the pairs of corresponding sides at angle? Can you really just go through and play a matching game when it comes to similar figures? Can you use this similarity statement to your advantage to figure out, hey, what sides match up with which sides, which angles are matching up with which angles? Okay, so proportions, this is what we were using to prove that two figures were similar. It was also what we were using to help us find missing sides. So that's what I want to do actually with the following example. So take a look at example number 2. It says, decide whether the figures are similar, compare the ratios of corresponding sides, and simplify the ratios. If the figures are similar, then we want to write that similarity statement. Okay, so what we're going to go through is we're going to go through and play a matching game. And remember, this is where we simplified all of our fractions. And if all of our fractions simplified to be exactly the same thing, then we knew that these figures were actually similar. So let's go through and play this game. So I'll start over here on the left. So take a look. I started at angle G, going all the way to angle F. So take a look at the markings. You want to make sure that you compare it to the same markings on the other figures. So I started with the one that had the angle with the little line going through it. So if I can find that, this would be point M. And then I went towards the one that just has one angle symbol. So be careful, be careful. Here's the one that has one angle symbol on the second figure. So it's going to be from N to L. So these are the sides that are corresponding. These sides are the ones that are matching. Okay. All I want to do now is I'm going to write a fraction. I'm going to set up my first fraction here. And I'm going to go from left to right. So I'm going to write 18 over 30. So let me write 18 over 30. All right. And then let's keep going. Let's keep playing this matching game with different sides. So let me move on. I'll go here from G to E. So the one that had an angle marking with a line through it. So angle marking with a line through it. And then the one that doesn't have any angle symbols, which in this case was M. So I'm going to do the exact same thing. Remember, if I'm going from left to right, I did 18 over 30. Be careful here. I'm going to say 12 over 20. The most common mistake that happens here is students will accidentally write that fraction upside down. They'll write it in reverse. They'll say 20 over 12. You want to be consistent. And then, of course, we have the last sides here, which are pretty obvious, right? From E to F, from the one that didn't have an angle symbol to the one that does, that's going to be M to L. So I'm going to write 15 over 25. Okay, so there's my proportionality statement. All I want to do now is go through and simplify those fractions. When I go through and I simplify those fractions, if I get the exact same thing, I know that they're going to be similar. So what can I simplify this first fraction by 18 and 30, I can divide that, let's say, by 6. By 6, I think that's the biggest number I can simplify by. 18 divided by 6 is 3. 30 divided by 6 is 5. So my first fraction is 3/5. Let's keep doing that with the others. What about 12 and 20? What can I simplify that fraction by? Well, 12, I can divide it. I think the biggest one here is going to be 4 and 4. So 12 divided by 4 is 3. 20 divided by 4 is 5. So far, so good. 3/5 equals 3/5. That's so far as a true statement. I have to do that one more time, and hopefully that last fraction is 3/5. So take a look. We have 15 divided by 25. I can simplify top and bottom by 5. 15 divided by 5 is 3. 25 divided by 5 is 5. And take a look. That actually checks out. 3/5 is equal to 3/5 is equal to 3/5. These figures are actually similar. Figures are actually similar. So let's go ahead and write that statement. So we're going to write that similarity statement just like we had in that first example. We want to write one of these statements. And again, the order does matter. So please be careful with this. I'm going to go ahead and start. I'm going to go from angle G. So I'm going to say triangle G. And I'm going to go over to F, and then over to E is similar. So take a look at the order that I went in. I went with G, which had an angle marking with the dash through it. So I want to start here at angle N. Whoops, triangle. If I can write a triangle here. Triangle, N. And then F had one angle symbol here. So I'm going to go over to L, which also had just one angle symbol. And then, of course, the last one. E didn't have anything, and M doesn't have anything either. So there we have it. That is our similarity statement. And this right here is how you prove whether two figures are actually similar. So this is your proof. And then this is your similarity statement. Okay. Let's move on to example number 3. Let's try it one more time. Decide whether the figures are similar. So I got to prove it using that proportionality statement. And I'm going to compare the ratios. And I'm going to simplify them, right? And then we're going to go through and write that similarity statement if they truly are similar. So let me start off here with, let's see, I'll start with A to B. From A to B is going to be matching up, well, one angle, two angle symbols, one angle symbol to the one that has two little angle symbols there. So let's go ahead and write our fraction. I'm going to write 10 over 20. You could go 20 over 10 as long as you're consistent with the rest of your fractions. But I'm going to go from left to right. So I'm going to write 10 over 20 is equal to, well, let's keep matching up the other sides. I'm going to go from B to C this time. The one that had two symbols, angle symbols, to the one that has three angle symbols. So there, I'm going to write 4 over 12, 4 over 12. And then I'm going to do that one last time, right? It's kind of obvious here. From C back to A, from three angle symbols down to 1, from three angle symbols here, from F all the way to D. So one more time, I'm going to write 7 over 21. Let's go through. So those are my ratios there. Let's go through and actually simplify. What can I simplify this first one by? What can we simplify 10 and 20 by? I can divide top and bottom by 10. 10 divided by 10 is 1. 20 divided by 10 is 2. So I get 1/2. Okay, let's keep it going. What about the next fraction? I can divide top and bottom by 4, right? 4 and 12 can both be divided by 4. So 4 divided by 4 is 1. 12 divided by 4, however, is 3. So right there already I can see that, hey, that's not looking very pretty, right? I had 1/2. It does not equal 1/3. But let's just simplify the last fraction here, just so you guys can see. 7 and 21, I can divide them both by 7. So 7 divided by 7 is 1. 21 divided by 7 is 3. So the last two fractions, right, 1/3 equals 1/3 was fine, but 1/2 does not equal 1/3. So we're not going to be able to write a similarity statement. These figures are not similar, right? And there is our proof that shows us, hey, these are actually not similar. 1/2 does not equal 1/3.